Good morning, everyone. Good morning. Welcome back. Glad to have you with me on another episode. Trust you've been enjoying this so far. Got another interesting topic today. Um, Hopefully, you enjoy it, this one as well. Um, Today, we return to the works of a man we have spoken about before, having previously dedicated an episode to him. I'm not talking about Euclid, I'm talking about the mathematician John Conway, whom we wrote episode 4 on, detailing the look and say sequence. Um, After he was done writing extraordinary long integers with extraordinary large amounts of digits on the walls of his home, spilling down the meridian line through Greenwich, most likely on his way to sub-Saharan Africa, he gave himself a new project to focus his energy on. This is what he called the reverse and then sort sequence. The reverse then sort, or RAT sequence. Um, the rules of which are simple. Take an integer, any integer, reverse the digits, sum the digits, sort the digits, and then repeat. Go back to the reverse stage and you keep on doing this. Um, Initially, John Conway didn't have any rules for this. He simply thought, let's simply do this until we get bored. Much like probably what Archimedes did when he was finding the digits to pi, or what John Conway was doing when he was determining the series values of the look and say sequence. There was no real terminus to this. However, John Conway decided or realized that without a plan for a terminus, we don't simply do that. Allowing for computer programs to run away without any logical terminus is a bit of a dangerous idea. Um, Anyone who's ever watched The Age of Ultron will understand full well what that means. So we're not going to do that. John Conway didn't do that. Only bad things happen. This is this is one of the reasons why I needed a new laptop, amongst many reasons which I will not get into in this episode. So if you came here to understand the origin of this beautiful Dell, you may as well stop watching. Or actually, don't do that. Please keep watching. So anyway, today we will examine the look the no, we're going to examine the rat sequence, and we will apply a terminus. So whenever an integer reaches an integer where all digits are the same, we terminate. Not because there was anything special about this such terminus, but it was a simple terminus amongst many. Um, so John Conway developed this. I believe it was after his work on the look and say sequence, which he published in 1987. So immediately after that, he worked on the rat sequence. So unlike the look and say sequence, the look and say sequence had been around, let's say, for centuries. The reverse and then sort sequence was something that John Conway, it seems, has made up himself. It was his own original literature, and I believe, he claims it as his own work. Um, so today we're gonna make a script that carries out the sequences for an integer or a load of integers actually, and we're gonna observe the output, see if there are any patterns, see what the behaviors are. Let's see. So today is October 6th, 2025. It's Monday. Let's do this. I have a blank instance of C sharp, and I'm going to do what I'm going to go simply get some packages in here, and as always, I have no idea what any of them are for. I simply start off with a load of them and see if I need them in the end or not. Okay, so link that. And I keep them here because I was trying a few things out um, which required these packages, and then I slowly, as I kept editing, I realized I didn't need certain things, so I got rid of them. Some will stay, some will not. So let's create this class. Let's call it any class. Okay, and what do I want? I'm going to, in a way, I'm going to start at the very end almost. What do I mean by that? So I've got what this will be is, let's say, functions on top of functions. Um, so I'm going to build those base level functions first. So let's try this. I'm going to first need a static string, and I'm going to find this, let's say, not a local function, but a function which I made up myself. I'm going to call it the reverse string. The string is s. So remember, s is the string itself. Um, So on what do I want that to return? I want it to return a new string where that integer that it takes is simply going to reverse the digits. That's what this is a C# function here. I'm trying to keep track of what is C# and what is not. So I'm going to recall that reverse string later. So you can see it's, let's say, not highlighted. It's in the dark font indicating I haven't called it yet. I'm going to do the same for the what do I want? The sort function, the static strings. We'll call that sort string. Do the same. So functions will be built on top of this. Um, okay, it's not so obliging today. Because I'm not setting this up correctly. That's why. Okay, so return a new string. You take the original string s, which is the input integer, order by c, whereby c we will simply impose to be the array. To remember, c are the characters of the string. Okay. Oops. Okay. To array dot. Yep. And I need, so you say there's references here. It says 0 references because I'm going to build the actual class on top of this, or the static void. So all digits same. So this is now recognizing determinant. So when the digits are the same within the string. Okay. And this will return the string whereby if all of the C or all of the characters within the string are equal to, and this notation here, this is telling me if all the integers are equal to the first digit in the string s, then we stop. Okay, so that's all well and good. I'm going to move on now. So let's create the static void. Okay, so static void main string, and I can use the arguments now. Okay, so let's put some daylight between you. Okay, so what do I want? I want to simply start off with, let's say, a minimum integer that I want to run this from. So let's simply call that 1. And I want a maximum integer to end with. Let's say equals 1000. And I want, let's say, a terminus. Remember that little word we had about runaway algorithms, computer programs. So I'm going to, let's say for now, this will stop at 40 steps if we haven't found a terminus. So what do I want now? I want to define what actually needs to be run. So for the start, let's define the start equals. So min start, I'm going to need the min start to be recognized. I want the start value to be less than the max start. And I want that to simply keep on going. Okay. Have I done something wrong already? It's not letting me. I've done something wrong. So numerics, you can see numerics is now highlighted in solid white. Don't think there's a problem. There's 3, yeah, this because I need to close off. What are you? Chosen invalid expression term. Yeah, that's right. Because I need to no, because I need to end the class. Yeah, okay, so hopefully that makes that happy. Yep, I've got rid of one of those. So console write line. So we're going to run the rats. Okay, rats being short for the reverse and then sort. So start max actions. Okay, and this is going to run up until the max actions. But how do we know what the max actions are? Is it 40? Is it 40 sums? Is it for 40 reverses? Pretty much all of them. I don't want it to run this for 40 reverses, 40 sums, 40 sorts, because then it gets a bit hectic. So I'm going to cap it at that. So write line, and I'm going to simply put a line space between all the progress. Okay, so now I want to write the actual function. So what are we deriving everything on top of? Or what is the thing that is deriving those bottom 3 functions? So I'm going to go away, get that out of the way. Okay, so let's build something. What do I want to build? Static underneath. I don't need that. No, I don't need that. Yeah, okay, I think I see what the problem is. Yeah. Yeah, okay, all right. That's it. Now I'm going to build the static string, which is the run rats. Okay, so this is the run rat sequence now, or the rat sequence. And you can see once again, it's telling me what I want to do. So the start number int integer max actions, i.e. these are all of the, let's say, parameters that I want to govern the behavior or govern the, let's say, interaction of the program. Um, okay, so let's see. I'm getting an issue here already. Is this how I wrote it first time? Okay, I think it is. Yeah. Okay. Okay. Now it's concentrating. That's not what I want. Yeah. Good. Okay. Okay, so now I want the string builder. So remember, it'll treat all the, let's say, input integers as a string. So instead of numbers which, let's say, store a lot or you require a lot of memory from the system, we're not going to do that. We're simply going to restore it basically as text. Okay, so output dot append, and this is where we simply start building. Dot u, so start. So recognize the start. Um, and the start number. Okay, it's telling me toString. I don't want that yet. So I can close that off, right? And now I can move on to, this is, that's not, yeah, string. Let's start off with the current string number. So we'll start off by recognizing what that first integer is. Start number dot toString. Okay, int, and we want to define the action count, so 0. So we start off with 0 actions. And there will be an end message there at the end. So end message, that will be like, okay. Okay, now, gotta be careful here. I was burnt by this before. While true. So, okay, so this is going to run. So while this is running and while we haven't hit an endpoint to this, uh, yes. So, let's start off with the reverse. So we want to build the reverse string. So this is the reverse function. And so now this is where I'm going to call this function here. So right now it has 0 references, but as soon as I call it, it's going to say it has 1 reference. So the string, um, we want to find a reverse string or create this new variable called the reverse string, which uses the reverse function. And now it's got that 1 reference, you'll see. Current string. It takes whatever that starting integer is. Let's say it's, I don't know, 100. So it'll reverse, maybe that 123, for example. It's going to reverse the digits. So now we got 321. Okay, so action count as long as there are actions to run over. Append. Okay, and let's say this is going to be the reverse step. Okay, so what is the output of the reverse step? Simply recall the reversed string 1. Okay, and is that correct? Yes, it is. You're correct. You're correct. Close. Okay. So what happens, because remember, we're going to keep on doing this until we find um, a string with all the digits the same. So the action count is less than, so you see here, it's referencing here. We start at 0 actions, but we keep going up until this if here is triggered. If this is greater than the max actions. Okay, so if we do hit the max actions, then don't need that. We recall that message. So what is that message going to be? So because we don't want it to run away, but we can't assume that it is there is such a string at the end where all the digits are the same. We have to assume that it diverges. Divergent. And if that is the case, then we simply break and move to the next. Okay, so that is our reverse function. Um, and all we need to do is the same for everything else, all the other subfunctions. So remember I said that we're building this while true, or this run rat function, or the rat function, built on all those original functions we had earlier. So we take the original and then we add the reversed. Okay, so I need to recall the original and I need to recall the reverse. So I've got 123 and I've reversed it. So now let's simply call that sum1. Is big integer dot parse. So passes again. Remember, I'm using the pass because I converted the digits somewhere into an actual string of digits, and it's not really a number anymore. So I need to use that pass now. So current string, okay, plus big integer, and I want to recall the not yet. I want to pass it, and I want to recall the reversed string one. Okay, so that's what that is. And we're still not done. So again, this will also oops, action count. Okay. Count, current string. That's wrong. I need the current string. Yep. What else do I want to output that again. So most of these lines would simply be the same even. So what's the message here? This is summed sum one. So it's going to output whatever that sum is. It's not going to show the intermediary because I think this will simply take up a lot of space. So here we go. If all digits are the same, and this is when we can start terminating the sequence, if we can. If sum one to string, and we're recalling, no, I want that one, close that off. We're recalling the all digits the same now. So if all digits are the same, then we can terminate this and move on to the next one. So then again, here we can end it. So end message equals whatever that message is. Just finish, I suppose. Finish, and we're going to break the cycle and move on. So similar to what we had up here. Okay. Okay. Otherwise, we can. I'm going to copy this because it's the same message. We don't want this to run away, so we simply identify if it's divergent or not. Oh, good. Okay. How do we? What's the next step? It's the sort. So we sort things out from here. So sort the digits, and that's in ascending order. So one, two, three. It's not three, two, one. It's one, two, three. So the string. Now we're going to recall the sorted function that we created earlier. So in the sort string, and you can see there should be a reference at some point. Sort string, no, sort string. And what was in there? That's the sum one to the string. Okay, good. So now everything has a reference. Okay, okay. Concentrate. So action count. Keep going. And so then I think I'll speed this up a bit. Otherwise, we're going to be writing quite a bit. But I don't want the reverse there. I want that sorted. Okay, and this will be sorted string. Yes. End, and if action count possibly divergent because it can't finish here. So again, I'm simply going to copy that. Okay, possibly divergent. Okay, and we start this again, but I couldn't do this by linking it back to the original integer that's been summed or sorted. For some reason I have to start a reverse here. I couldn't make it work before, so I'm a bit confused by that. So sum string 2 is equal to the reverse string sorted string. Okay, so, and again, action count, plus plus, output dot append, and I need a message. Okay, and I want to output that, so reverse, nope, to reduce the reversed string to end. Okay, so, and again, the divergent message. Divergent. Okay, and then finally, I want another sum. Okay, second sum. I don't know why, I don't even know why I need this. If I have to use that, I for some reason I have to do this. Add another sum. So, what do I want? Big integer again. Sum 2 now. Big integer. Sum sorted string plus the reversed string 2. So the thing that we did, what did we do? No, big integer. Big integer pass reversed uh, reversed string 2. Okay. So what do I want? Action count. Great. Yeah. Okay. So again, I want a message. Almost finished. S- Sorted string plus the reversed string 2. That was supposed to be a parameter that I recall, so I need those brackets. I guess I did want some. I said earlier somewhere that I didn't want the sums, but I guess I do. Okay, sum 2. Okay. Oh no, I want to end that. No, I haven't. I've ended it somewhere where I shouldn't have. That's you. Yeah. Okay. Okay. So let's end this. I'm almost finished. So if all digits, if, and so I can end this here. No, I'm getting confused writing that, so I'm just gonna add you in there. But I'm going to be careful. If sum 2 to string, end message finish. Yes, I want that. And possibly divergent. Okay. Great, great. So now, for some reason, I can add in the loop here. So I'm going to replace the current string with sum 2. So this simply starts the sequence off um, with that sum 2 figure here that we created. So there's not a great deal left to do. In fact, I think there's only one thing left to do. Again. And I need to simply output the line. So output append line. Yeah. So it's similar to console write line. But because we're creating results, we have to use this append instead of console write line. And this is simply the output. Return output string. String. Great. So I've got an error. Why? Where? What? What? To array. Yeah. Why is that? I'm missing. There's an extra bracket, 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 bracket. Okay, I'm supposed to do that. So no issues found. That's great. Okay, let's run it. Do that again. That's pretty cool. So what happened here? So um, reversed. Let's start with 5. You take the initial starting number, start the series. 5, reverse it, you get 5. Sum it, you get 10. 5 plus 5 is 10. Sorted, 0 and 1. So that's a good point. We're recognizing the digit 0. Otherwise, I don't think this will quite work. And I think we'd simply collapse at 1, and then we'd simply be starting again. Reverse it, 10, summed, 11, and there we go. We get a string with all the digits. String where all of the digits are the same. So let's just move on to something exciting. 19, things seem to get out of control here. So what happens here? 19, 91, summed, 110, 11. Yeah, okay, I think that's it. Are these the steps? I'm not sure. Reverse, and then sort. Yeah, so looks good. So again, you see for the most of these, okay, so what's happening here? Divergent. Let's sort of look at some of these behaviors. So again, if I simply scroll down, you can see it's done it. What is it? 270 reverse 072 sum 342 234. Yeah. Okay. What else we got? 8 otta 362 263 16. Yeah. I mean, the sum is working out. I mean, that looks good. Okay. So what's happening here? Possibly divergent. So you could see. Okay. Look at that. Forces that. Okay. And all the way at the bottom. I mean, it simply caps off here. We're finished. Reverse 1000 a bit. Okay. So that's pretty damn good. So look at this. 19 is the first one that is possibly divergent. So I did some reading on here. 19 is divergent. There is people with more processing power than I can, that I have ran this for, let's say, a million steps, 10 million steps. I can't remember the number, but a lot of damn steps. If they can't get it, what hope do I have? And you can see there's this number here, 110. The first sum is 110. If I go down to 28, we've also got 110. And then this final number here, this 988686889 is the same here. And I believe that's a palindromic number as well. You read it the same forward and read it the same backwards. So here's 37 again is divergent. So 37, you get there's that number 9886 etc. So 46, and you can see it. Yeah, this sum, it's that first sum that reads to 110. Okay, so if I go to 110, it's not the same. I think 110 is actually fine. 110 is fine. It finishes it. It converges to 5555. So interestingly enough, it seems it's this 40 steps. If I hit this the simple number 40, whereby this is the 40th step, 40 steps, it hits a palindrome. But anything else that diverges, like this here, I believe this is also a palindrome as well. 565, yeah, palindrome. I picked 40 out as a random number, so maybe there are others. See there, that is not a palindromic number. Uh, okay, yeah, fine. I mean, yeah, we can go along all of these, but if I were to type like 9888, look, that's a palindromic number. But I remember if I typed in that, I think that was not a palindromic number. Um, but anyway, that's it. That's kind of interesting. The what was it? Interestingly enough, I see this number. What is it? Typically, if it's not divergent, then we've either got one, two, three, four steps, or we've got it's mainly that 7 steps, isn't it? So 39, it starts, it recognizes 39, it reverses it, sorry, um, sums it, sorts it, reversed, sum to give 44, and then it terminates. So yeah, okay, so it terminates. It seems like 7 steps is rather interesting. One, two, three, four, five, six, seven. So it terminates for the most part. It terminates after 7 steps. So I remember when I did this like years ago or something, it was seven, one, two, three, four, five, six, seven. So remember, because we're using the terminus of the this digit, all digits are the same within the string, or a number where every digit is the same. That is the terminus. Otherwise, we keep going. So by that means, the end is an extra step in itself. So there you go, 7 steps, and that's it. Yeah, that's interesting. So for a lot of these numbers, 7 steps is the let's say the magic number for it. One, two, three, four, five, six, seven, seven. The end. So, uh, I mean, we can ask ourselves sort of why that is. Back in the console or the right. So I think it's simply this. That is recognizing the end. So, I mean, again, I said it's not. We don't have to set 7 as the end. 7 steps as the end. No, that sort of terminus. There are other ways we can recognize a terminus. John Conway thought that was the most practical, I believe. I don't know. I'm sure there are many other ways we can terminate this sequence. Um, that's really interesting. I'll explain that again. So we're setting parameters here, the minimum start. So we're simply running it from 1 to 1,000. We could change that if we really want. We can go for like 1,000,000 to 2,000,000, etc. We want to cap this off at 50. And here we are simply defining the reverse, the sum of the original, sort the digits, um, reverse it again, etc. But we needed these intermediaries to go along. So, oh well, there it is. 7 steps seems to be the way. The number of steps here for most of them. Uh, Guys, I'll leave it here. Thank you so much for watching. If you have any questions, let me know. Always happy to hear your comments and thoughts. And yeah, stay tuned. Keep following the series. I hope you're enjoying it. I hope we can make it things more interesting, more entertaining for you. So yeah, just let me know. Let me know what you want to see. Let me know any thoughts. I've got plenty of ideas for these series, for these programs in C sharp. So yeah, gonna keep on making them. It's October 6th, 2025, Monday. Get this video out soon. Thank you very much, everyone, and I will see you next week for another video. Thank you. See you soon.